Hello everybody. I feel like I haven't seen you guys in a while. This is Unit 4, Prerequisite Skills 2, Screencast Notes. So I'm going to start out with vocabulary, start out with factoring. Factoring is undoing the distributive property. So when you're factoring something, you're going to get something in expanded form. So you'll be moving from expanded form to factored form. Whereas in the previous screencast, we were going from factored form to expanded form. A couple other vocabulary words here. We have greatest common factor, or the GCF. This is the same thing it meant in 6th grade, but just a review. Greatest common factor, the greatest number that each coefficient can be evenly divided by. Okay, and then lastly, we have the greatest common variable. This one is kind of made up. Greatest common variable is not a real thing, but it's all right. I just put it together. It's the same as the greatest common factor, but it's the greatest power that each variable has in common. I'm actually going to write that definition up here at the top because I don't think you're going to be able to see it at the bottom. So this greatest common variable, GCV, again, something I made up. It's not a real thing, but it'll help you to remember, hopefully. This is the greatest power that each variable has in common. Okay, and now that we have a couple of vocabulary words, we'll start talking about actually putting these to use. So, factoring out the GCF and the GCV. So the first thing you want to do, first, look for a greatest common factor. Look for the GCF. And second, look for the GCV. So, example 1, if we're factoring 5x plus 15, it's a weird little 5 there, 5x plus 15, first thing I'm going to look for is that GCF, so greatest common factor. So I look at my coefficients, so 5 and 15. What is the greatest number I can divide into both of those and still get an even number or a whole number out of it? And the answer is 5. Then I look for the GCF, the GCV, greatest common variable. What variable do they have in common? Well, this one has an x, this one has nothing, so there is nothing. There's no variable that they have in common. So I take that greatest common factor, and I now divide that out of my term. And when I do that, I end up with 5x divided by 5 is just x, and 15 divided by 5 is 3. It's positive, so I get a plus sign. And this 5, my greatest common factor, ends up in front of the parentheses. Now, I can check this by distributing it back. Excuse me. Yikes, that one snuck up on me. Okay, so I can check by distributing. So 5 times x plus 3, 5 times x is 5x, and 5 times 3 is 15, which is exactly what I started with. So I know that I'm correct. Let's look at the second example. Example 2. Factor 10x squared minus 16x. So we'll start out, greatest common factor between 10 and 16. So let's see, 5 goes into 10 but not into 16. 2 goes into 10 and into 16. And I think that's it. We got 2. So we'll divide by 2. And we'll look at our greatest common variable. Now there's an x and an x. This one has an x squared. The other one just has an x to the first. So I can only take out the greatest one that they have in common. The greatest one that they have in common is just x to the first, because the minus 16 doesn't have squared, so I have to take out just x to the first. So just the x. So I'm going to divide everything by 2x. So when I write this, my parentheses, 10 divided by 2 is 5. X squared divided by x to the first. This is where our rules of exponents come in. We subtract. So 2 minus 1 is just an x. 16 or negative 16 divided by 2 is negative 8. And x divided by x to the first, they are just going to cancel. So it's just going to be the negative 8. And remember, this 2x, my greatest common factor, greatest common variable, have to come out front. Okay, and you can think about distributing this back. So here would be my answer. If I check, I would have 2x times 5x minus 8. I distribute, I'd get 10x squared and minus 16x. We can also do this with an area model. I could draw my area model 2 terms, so I'll just have 2 boxes. This would be 10x squared and negative 16x. I'm still going to need this. I'm still going to need to do the work of the greatest common factor, greatest common variable, and that's what's going to go on their common side, because both of these terms share this side. So that's where my 2x would go, and then I would fill in the missing pieces. So I would ask myself, 2x times what is going to give me 10x squared? So 2 times what is 10? So 2 times 5 is 10. And x times what is x squared? And that would be x times x. And then jumping down to the next one here, 2 times what is negative 16? That would be negative 8. And x times what is x? And that would be x times 1, which I don't need to put in here. So I would end up with this here. This would be one set of parentheses, which since it's just one term, I don't really need to put parentheses. And then this would be my other set. And I would end up with 2x times 5x minus 8, which is the same thing I got up top. Okay, example 3. We are factoring something a little bit larger now. 12 x to the 4th y squared minus 30 x y to the 3rd plus 24 x squared y to the 4th. That doesn't really look like a 4. Hold on, let me fix that before I confuse myself. Okay. So again, starting out with the numbers, greatest common factor. GCF. So right away I thought it was 12, but 30 is not evenly divisible by 12. So let's run through, how about what's the next? 6? They all divide evenly by 6. So greatest common factor is 6, so I'll divide all of these by a 6. And now my greatest common variable, I'm going to have 2 of them because I have an x and a y. So I'm just going to look at my x terms first. I have x to the 4th. I have x to the, I'm going to put in the 1, the first, and I have x squared. So the greatest that they have in common is just this x to the first power. I can't go any higher than that. So greatest common variable for x is just x. And then I look at y. So I have y squared, y to the 3rd, and y to the 4th. So the greatest one that they have in common would be squared. So I can take out a y squared. So now I'm going to divide out an x and a y squared out of my term here, out of each term. So I set up my parentheses, be a little bit longer than usual, out front, I can put what I have already, 6xy squared. That's what they all have in common. And now I'll do the division. 12 divided by 6 is 2. X to the fourth divided by x to the first, we subtract, so 4 minus 1 is x to the third. And y squared divided by y squared, those will cancel, leaving me with no y's in my first term. Okay, minus 30 divided by 6 is 5. X to the first divided by x to the first, those will cancel, so I'll have no x terms. And y to the third divided by y squared, subtracting 3 minus 2 is 1, so just 5y. And then lastly, 24 divided by 6 is a positive 4. X squared divided by x, so that's 2 minus 1 is a plain old x. And y to the fourth divided by y squared, that's 4 minus 2. That leaves me with y squared. And this would be my solution for that one. Again, if we wanted to, we can do an area model for this. Be a little bit longer this time because I have 3 terms. So I have 12x to the fourth y squared and negative 30x y to the third and 24x squared y to the fourth. Again, I would still need to do this work here and get my common factor, which I have as 6xy squared, and then I would fill in the blanks. So 6 times what is 12? 6 times 2. X times what is x to the fourth? That would be x to the third. And y times what is y squared? That would be just a 1, so I don't need to write it in. 6 times what is negative 30? That would be negative 5. X times what is x? That would be 1, so I don't need to write it in. And y squared times what would be y to the third? That would be just a y. And then 6 times what is 24? That would be just a plain old 4. X times what is x squared? That's an x. And y squared times what is y to the fourth? That would be another y squared. This would be my first set of parentheses, which we see right here. And this would be my second set of parentheses, which we see right here. So whichever method you prefer, you just go with it, and we just go right from there. Okay, so let's see, we have example 4. This one, oh no, there's no example 4, is there? My pages got all mixed up here, hold on. Factoring out greatest common factor. No, that's that. Okay, so now we're on to factoring trinomials with no greatest common factor. So now we have, remember we're undoing expanding. So now we're going to have a trinomial that has no common factor. Now let's do some notes here. So under the notes section 1, you're going to want to put the equation in general form. Got a new pen. I don't know if I really like it all that much. It feels like it's kind of just has a mind of its own. So remember, general form is a x squared plus bx plus c. A, b, and c are all numbers, but they go in that order so that the highest degree term is first, and in this case it's your x squared term. You need to identify your numbers for a, b, and c. So identify a, b, and c. The third thing you're going to do is find two numbers that multiply to equal c and add to equal b. And then you'll rewrite in factored form. Factored form are your sets of parentheses. Okay? So, starting with the next couple of examples, these examples are when a equals 1. And then we'll see when a is greater than 1. So when a equals 1, so example 1, we have factor x squared plus 12x plus 35. So there's no greatest common factor because the a term is 1, and the greatest number that goes into 1 is obviously 1, and dividing out of 1 doesn't help. So where do we go next? We identify a, b, and c in our equation. So here's a, here's b, and here's c. So a is 1, b is a positive 12, c is 35. So now, just like I said in the notes, we need to find two numbers that multiply to c and add to equal b. So we need to multiply to 35 and add to 12. When you think of multiples, when you think of two numbers that multiply to 35, what comes to mind first? Mine is 7 and 5. So 7 times 5 is 35. And if I add 7 and 5, I actually get 12. So this is nice. The first try, I got it. So now we split up factored form. So this would be x. We split up the x's. So I have x in one set and x in another set. And I would have a positive 7 in one and a positive 5 in another. And this would be factored form. Don't get too excited. They're not all that easy. But let's look at what it would look like with your area model. So your area model, even though there's 3 terms, this came from one of our square boxes because we had 2 sets of parentheses and we had the like terms that were combined in the previous, like we had in the previous prerequisite skills the other day. So this one here, we would have our x squared term here and our 35 would go here. And what we're trying to figure out is what are the 2 terms that we would add together to get that middle term, that 12x term. So if I use my area model, I still kind of need to do what multiplies to 35 and adds to 12, but this is more of a guess and check. So we know to get x squared, we have to have the x and the x, and that's where it comes from here in the parentheses. To get 35, like I said, the first thing that comes to my mind is the 7 and the 5. And then I would fill in the other parts of this box here. So 7 times x is 7x, and 5 times x is 5x. And then we check. So if I add 5x and 7x, I get 12x, which is exactly what I'm looking for. So I take my 2 sides, my length and my width, and I do x plus 7, which is what I have right here, and x plus 5, which is what I have right here. And I would rewrite it like so. Okay? That's the first example. I'm going to pause here and screencast the second example, third, fourth, and then we'll look at if A is greater than 1, how we can do those.